everything that can go wrong is going wrong. I need to get this power back on again. Don't let anyone ever put you down for having parkside tools. We're having an absolute nightmare. It's just doing my head in a little bit. This morning, my van broke down. Join me today as I wave a big metal sheet around some flipping ginormous cables with the power to kill me. And there's some dirt on the lens. Hi guys, welcome back. Have you ever wondered how power is generated? The power that's coming inside your house right now could well be coming from one of these generators that I'm sitting inside. However, this one in particular has broken down. So my job today is to see if we can get it running and get this massive gas engine switched on again. So I've managed to land a contract basically maintaining these gas turbines across the country. These engines, what they do is they prop up the grid. So in areas where the UK power network grid can't cope with the power that's needed, these engines basically sense that and will then kick in and just provide a little bit of extra generation. But this one here has broken down. I think I know roughly what has caused it and how we're going to get it going again. Like you can see there, this is all burnt out. By the way, don't worry, this is all very safely isolated. We've got HV coming into the building, high voltage, and that is isolated from the other side by an authorised person. So we're safe to work in here and this is all dead. So there was a fuse carrier that sat there, but the trouble is it wasn't just the feed in and the feed out that was in there. You also had these cables here. So this goes over to a scope over there, which I'll show you later. And this here does a G99 device. So if you imagine the grid has already got a generator somewhere ticking over and you've got this here that's out, you can't then introduce that onto the grid. You have to wait until they're synchronized and then it will click and put in. So that's what this cable was doing here. Trouble was, you had all of these twisted round together and then twisted around that cable, which has then caused it to burn out. So before we can switch this machine back on, we need to engineer a better solution to fit inside of that. To be honest, it's going to be a bit of suck it and see this afternoon because it's a very last minute call out and it's just a case of we need to get this gas engine up and running again. I'll show you the HV side, how that works, I'll show you the actual gas engine. So if you're mechanically minded, you'll find that interesting. And also we'll show the actual electrical repair in here. So it's a little bit to keep everyone happy. Invite your nan along, get a bag of crisps, sit down, enjoy. Right, so this here is the HV. So this is where the power will be coming into the property. High voltage in the UK is anything over 1,000 volts. So typically inside there you'll have either 11 kV or 33 kV. That will be coming then through a breaker up to this transformer here. That HV is still live, but we're not touching that side of it. It is then stepped down to LV, which in this instance would be 415 volts. It's safely isolated and then off of a breaker in there, up into the panel in question. Now these two generators over here, these gas engines, these operate high voltage as well. So these are both HV and these could kick in at any time if the grid feels it needs it. But these are safely isolated from this engine here, which is running in LV. So step one, let's see if we can get this actually fitted. If we can get that fitted, then everything else will sort of bolt onto that. So come on inside. Right, so first things first is going to be try to make space for this little panel. Loosen this off, this DIN rail, we'll reuse that elsewhere. Or even though all these cables are dead, let me tell you, it's still so uncomfortable working next to large power. I mean, it's silly really, because you should have this attitude with all power that it can kill you. But it's like, when you get into larger power like this, especially when you've got the transformer and the generation so nearby, you get massive amounts of potential fault current. Not only have you got the risk of electric shock, you've also got the risk of things like arc flash. Come on, mate. There we go. Not really comfortable putting that cable underneath. That fits. Join me today as I wave a big metal sheet around some flipping ginormous cables with the power to kill me. There's a trainer for you. Oh. I don't like making things janky. Why are you trying to make me make things janky? I thought rather than bolt onto this, we'll make something really nice and professional looking, but it's going to be really uneven and look horrible. Something is throwing it off, and it's all these bolts here, and actually it's probably nice for them to have access to those bolts for when they need them. So what I'm going to do is I'm going to cut those bolts out so that they still have access to them on the axes of this panel, and then I should be able to just screw that right up. Right, this is cut and ready. See if it fits. This is probably where I wish I tested it off camera first. Like a glove. Now they can access everything. I just need to give it a little file. You get the gist of it. Now they can access all their bolts and everything still. So if we just dry fit this in place. Okay, so this steel plate is fitted, that is in, and that is fitting like a glove on a foot, which if you have a hand-shaped foot means perfect. This right here is where everything is going to go. Now these cables I want to replace, so I've actually got some 35mm proper cable that is actually designed for this type of thing, which I'm going to lug onto there, and some heat shrink, etc. So the next plan is to take that off, but I really think it's going to be a beast to do because I'm going to have to get around the back as well, and obviously these need to be torqued up really high. I'm going to speak to the supervisor off this job and see if he's happy me keeping these together, just because as well we're racing the clock today. I need to get this power back on again by tonight. Which is why I apologise in advance if the camera work and the storytelling and that is a little bit off today, because it is literally just a case of all hands on deck, get power up and running again. The next step is going to be taking the lugs off of these. Now let me tell you something, even though I know this is dead, it is really terrifying taking off 630mm cable connectors with some Parkside tools. However, I know it's dead, I've safely isolated. Otherwise, hi HSC board, I hope you enjoy watching this video. My name's Corey and I like long walks on the beaches and turtles. That's my obituary, just in case. Oh, no, we didn't need it, it's dead. Right, the fellow who's coming later, who you shall meet, he is going to help me switch this all back on and liven it all back up, but he has got all the torque bits and pieces. He's going to be torquing the torque. So for now, I'm just going to get it nipped up, or nipped off I should say, and we'll do all the proper bits and bobs later. Don't let anyone ever put you down for having Parkside tools. Parkside is middle out, but some of their stuff is brilliant. I'll tell you what, this has not been torqued. This is been done with a impact driver, I think. There we go. Put it off that time. See, the thing is, a lot of people think of a trade as a backup job, but not me. I love working long hours, underpaid, never knowing when I'm coming home and everything. I never wanted to be an astronaut. I always dreamed of having wrinkles just specifically related to the frowns of the day-to-day stresses and pressures of being an electrician. Oh, flipping heck. I need to completely redesign my van and my toolkit, because if I'm doing more, I used to do more of this heavy-duty type of work, but I've not done it in a long time. I've turned myself into a house basher, which I hate. Not that I have anything against house bashers, but what I hate is I now feel woefully unprepared. Like, I don't even have a bigger set of shifters than this. This is my biggest set of shifters currently, and it only goes up to 52mm, which is not going to be big enough for this sort of work. So now I'm getting more of these types of contracts again. I shall be 1000% upgrading my toolkit to slightly more industrial friendly and higher leverage tools. They're the old tails out. Now I've got the new tails to fit. Part of why we have to replace these cables, I don't think those old ones were rated high enough, to be honest with you. That's why I think they feel so stiff and brittle. I think they've just had a bit too much power going through it, so they've kind of slowly been getting cooked. Great little hack for doing these that someone showed me. If you mark out where you want it to go, cut just before that, strip that off, and then strip off an extra little ring, but don't let it come off. Slide it forward your extra little bit, put it on, and then you can just get your knife and just chop straight through that little piece there then. And then Bob's your uncle. You have a lug on with no fighting, no difficulty, and it's right to the end. Ready to crimp.
This is very difficult to film in a very small space with lots of tools and big cables,
but I've got this, which I'm loaning off of a friend.
I may be sponsored by Milwaukee, but they don't love me enough to send me one of these yet.
But let me tell you, they are absolutely amazing.
If you're watching this, Mr. Milwaukee, please feel free to send me one.
It just will make this job so much easier. Just for crimping these larger cables, it goes up to 150mm, I think. No, tell a lie, these dies go up to 300mm actually, so just makes it a lot easier when you've got lots of cables to crimp. So I'm going to smash these out, work my way through crimping these. I'm going to get heat shrank, and then I'll come back to you. Right, so that is what this will look like when it is all crimped up and heat shrunked. However, the other end, the fellow who is the authorised person here, he is coming back bearing gifts such as the 35mm M12 lugs, so I can lug it on that side and also torque it up properly. I just wanted to say, take a seat, as you already have. When you watch Kevin McLeod, right, present Grand Designs, you never know when he's having a bad day. Part of the reason why is because he's got absolutely tons of money. And as everyone knows, money solves all the problems in the world. And the other reason why is because he's a professional. Now here's the thing, I'm not a professional. I'm an electrician that lugs around a camera, sometimes a camera attached to a person. It does not make me a professional. When I'm having a bad week, I'm not often very good at hiding that on camera. But today I feel like I'm being really grumpy because I've had a rubbish week. Everything that can go wrong is going wrong. It's like coleslaw, Murphy's Law. It's just doing my head in a little bit. However, we will pull out of it. And once this job is done, I'll be really happy. Like, just even this job has been a nightmare and I've had to squeeze it in and a lot of travelling, and I'm already really tired because all that Stella's Kitchen volunteer stuff, that was only last week that we finished that. So I need a holiday is what I need. But what I need to do more is to get this on. So we can't really finish crimping all of these until Matey gets back with the lugs. So what we can start to do is start to mount these. So these fuse carriers basically hold the fuses inside there. But we're going to mount these on to this steel plate around here. Mark them up. We'll put them nice and low. I think that is as low as we're going to be able to get that one. Sorry, where's me saying, honestly, trust me, I'm not a professional camera presenter person. And you're all going, yeah, I believe you. What makes me laugh is when I see comments occasionally, and I'm not being big-headed making this up. You can go back through other videos and search this up. It's when I have comments saying, oh, you wait till BBC get a hold of you. You're going to be taken on. You're going to be hired by the BBC. Mate, I would be sacked faster than I could say BB. I'd be gone. You don't see the amount that is edited out of these videos, the amount of chaos and heartache that I cause the editor. Right. A little schmirkle there. A little schmirkle there. Right, so we're going to be drilling and tapping all the components on there to mount them. To drill and tap basically means you drill and then tap a thread into it, then use a bolt, in this case a little panhead M5 bolt, to actually fix and attach everything to it, so then you can take it in and out and maneuver things around. I'm going to show you something which I only learned last week and it blew my mind. This is, I think, the same on all combi drills. Once you finish tightening them, twist them back and it locks the drill bit into the chuck. I've used a drill every day for the last long time and I never knew that. Now I know that. Right, so where I've marked the holes, we're just going to drill through. Nice and slow. Make sure we got a little teeny bit of cutting compound on there. Nice straight hole, because you're going to be threading it soon. If you're doing a M5 thread, then you need a 4.2mm drill bit. Okay, nice. So now we select our M5 threader. Pop that in there. And pop this in there, doop-a-doop-a-doo, and then all we do is we just get it nice and straight, parallel to the material, a bit of a push, gentle pressure, and then we just turn it like so. And because it's only 2mm sheet material, it's not going to be many turns in there really. There we go, that's bit now. Beautiful. And now our little bolts should just bite straight into that. Yeah, there we go. That is a really nice method for fixing things, which when you're panel building really is the only way, at least that I've been taught. So proper pan head screws, never countersunk, and put into that. In a domestic setting, it's not really going to be necessary, but when you're doing any sort of panel
work or whatever, I feel like it's a must.
There we go, solid. Goes in there. Okay, let's get the next one marked out. So I'll quickly smash that out and then I'll come back to you. This is the face of a happy engineer because I've just had the engineer who's running the site pop back and give me a decision which I've been waiting for, which has been holding this whole thing up. You know who you are, and yes, I blame you. You have full blame for this. So now we have a decision made. So I've started putting these on. So if we come around here, I'll show you. These little luggy lugs connect just onto there. So these now will be coming down, along and up and connecting onto these, and then back down, along and up. So this is going to be my input, so I'll label that as such, in. This is going to be my out, out. Very hard to write. So we can have our input, our output. I'm going to link across the top there. I'm going to double up the lugs up to this DIN rail up here, and onto that I shall have a 250 amp connector block along with a breaker for the G99 references up there. Oh, and I can actually finally build this thing, and then I can give you the most exciting tour you've ever had in your whole YouTube channel history. Let's drill. Now it's time to get these other cables in. So I want to keep these as long as possible. It'd be lovely to cut these down nice and short and make them look lovely. It's really important that they actually are long enough for future. So we'll get this lugged up, ready to connect. Yes, I crimp it a lot more times than I have to. I know you only really technically have to crimp once at the top, but I much prefer to have it double crimped just to make sure it's definitely tight and so that I can sleep at night. So we'll be going back here, like so. Right, time for a quick update before it gets dark. So the G99 relay is wired up, ready to go. Ready to be wired up, ready to go. So that is the device that we were talking about earlier for synchronization with the grid. We've just chucked this Copex in. That runs down, and then you have these 2.5 mils that are coming out and into that breaker. These are mostly wired up now. I'm just about to lug them up and do that side. But in the meantime, our authorized person has arrived. Now this is Jamie. Everybody say hi to Jamie, be nice. People get so awkward when they meet their heroes.
I know you've been like it all day.
But I just want to ask Jamie, first of all, thank you for coming down. We've only ever had 2 bleeps in the history of Oi Electrical, and I really want to keep it that way. This is a child-friendly channel. Oh, that sounds bad. This is a PG channel. So yeah, can you show us a little bit about these engines and also how the G99 works? Because you see, Jamie here is the man on this site. So
I'm not an expert. I'll tell you, I understand. So the work you're doing, this is the synchronization breaker.
Yeah, so that's an ACB, so an air-filled circuit.
ACB.
Or you call it sometimes a GCB.
We call it a GCB for generator circuit breaker thing. But basically on that side, we've got the grid, and on that side, we've got the generator, and we want to connect them up. But if they don't match, then bad things happen, which is what all the G99 is for, and that kind of thing. So the G99 basically keeps the parameters right for the grid, and then the other cable we've put in, which is this one, I think, isn't it?
Yeah. That
goes to the synchroscope, which is this stuff, the generator controls.
Yeah.
So when the grid's doing this, the grid's moving, we're moving. When they match, we jump in, and that closes, basically, in layman's terms.
That makes sense. So this ACB then will clonk in. Okay, so do you want to show us around the engine?
I don't know anything about engines. This is a different engine. This is a nicer engine, actually.
So this is HV, this one.
This is HV. Let me get the lights on, then you won't have to.
You got all the controls. Ah, nice. So this is a V20 engine. You've got an ignition rail up here. This is a heavy duty piece of kit.
These are tiny. These are babies.
It's funny because to me this is really big.
This is really big to you, but to us it's a baby one.
Because these are quite notoriously a pain, aren't they, for breaking down?
The ignition. So obviously the timing's critical. They come in diesel flavour, landfill gas, which everyone says don't work on because it's horrible. It's like full of rubbish. And then these are natural gas, which keeps them quite clean. But yeah, the timing, not something I profess to know much about.
So these are just effectively big spark plugs.
Yeah, it's basically just a normal 2-stroke engine. No, that's wrong, isn't it? 4-stroke engine.
Yeah, 4-stroke times.
Suck, squeeze, bang, blow, I think that is. But most of the stuff we do is protecting the engine, protecting the asset. So all the stuff we do on the EC&I, and like we're doing today, is all about protecting this.
Right.
So that's the most of my job. All this blue stuff is handled by someone else, and all the protection, making sure it's in sync, making sure it's not over temperature, that's all the EC&I side of stuff that I deal with. You don't start them cold, it'd kill them. So they're always kept warm. So we've got circulating hot water. There's somewhere on here, there's an immersion heater. There'll be a big immersion heater. When it's running, we use these pipes to cool it. There's fans outside. And when it's stationary, we heat it.
Do you recover any of that heat?
That's the problem with peaking, we don't. So there are places where there's like a version of Centre Parks in Germany, and no, because we get some engines off them, and they run 5 or 6 of these engines in a CHP configuration, and they get every single bit out of it. They extract the heat from the engine, the exhaust, the lot.
CHP being combined heat power.
Combined heat power.
So any of the losses that come from cooling or heating the engine, basically, you take that potential difference and use it to either heat a room, space, water, whatever that might be.
So unfortunately, yeah, because of the nature of what we provide,
you're more just about getting the power out there. I suppose the trouble is where you are, what are you going to use that heat for anyway?
It's effectively, yeah, even if it was next door to like a biosphere or a greenhouse, we don't run. We only run when the need's there. So even though it's not economical to keep engines hot all the time, because the way we help the grid, it's more economical, if that makes sense.
It's got to be ready, it's got to be on
because you're ready, you've got ready, so the engine's got ready to go. So that'll be, like I say, this is hot. This one's not ready to run, but we keep it warm in because it's just better for them. Don't get condensate and stuff.
Cool. So the power's coming out of this.
Go down the business end.
Through to the business end.
Watch out, 'cause there's batteries down there.
Yeah, so it's fascinating really, because you're watching this right now on a TV or a laptop or a phone or whatever, but however the weather, everything that you're doing right now is based off of one of these. If you're connected and you're online, it's all come back to an alternator, unless it's via solar PV, or electrochemistry, which is very unlikely, especially at this time of night. It's either going to be a nuclear station, a gas station, a coal station, whatever, something that is spinning a turbine through an alternator.
So even with solar now, solar is non-kinetic, there's no movement, yeah?
Yeah.
But what they're putting in now is, I think the National Grid are doing it, they need the spinning mass, so they're putting in flywheels for solar.
That's fascinating.
Because when you've got the spinning mass, you've got the oomph, the power, and solar's got no oomph. So they need that oomph. So I think there's a power station on the Guy Martin programme up, I can't remember, and I hate silence on the video, but there's a power station where they've decoupled the plant and they just spin it as a flywheel to keep the grid stable. That's what we do. We help keep the grid stable along stuff like that. So you need the spinning mass. So somewhere there's something spinning. There will always be something spinning as well.
Fascinating, isn't it? And it's like such old technology, but it still works. So it's coming out of the HV from the alternator and then basically back through into...
So yeah, this, like, because we need LV on site, so if you look out here, look, you'll see they're the same engine, we probably bought the same.
Yeah.
They're HV, we always tend to have an LV engine as well, which takes care of our local stuff. But yeah, that's just pumping straight out 11,000 volts, straight onto the grid.
Do you have any 33k on site?
We've got 132.
Right.
So we've got, most of it's 11, most generations at 11. I don't think we've got any 33,000 sets. I don't think there is many 33,000 sets, I think it jumps up, but most of ours is 11, and most of it, once it's made in there, it's right. It comes out of that, grid ready.
Right.
Straight out the grid, we don't have to do anything to it, it goes straight out.
Fascinating. Cool. Should we get that thing wired up?
Let's do it.
All right, so we're in here cracking on. I'll show you what I'm doing here if you drop down and in. It's very messy, but once it's tidy, we'll be able to work out what I'm doing. So this is the neutral, which is coming along there, up, zip tied on, and swings round and onto the lug. So that needs to be tightened up and torqued up and all the rest of it. This is the line, which will be dressed round nicely along there, zip tied on, and then we'll just pop in like that on there. And I'm gonna work my way across doing all that while Jamie is up there doing that. What are you doing up there, Jamie?
I'll do reference voltage because seeing as it's me that's going to have to get it going, I'll get it. I just don't want the stress on you at this time of night. So, oh, that's flashing again. It scares me every time.
Every time you cut a cable.
It's almost like I set that up for TV, but that's actually happened today. So yeah, as soon as it's late at night, I'll do the reference voltages because then I don't have to blame it on you. I'll take the hit if it's wrong.
What can go wrong on them?
So because it's G99, the engine would refuse to sync. So it's looking at each individual phase and its rotation. So if you remember in the burnt out one, there's a reference voltage, which is this G99 one, and there was one for the synchroscope.
Yeah.
So they need to be exactly as they were because the G99 is set up for that setup basically.
Yeah.
So if they're not right, when we come to do a sync, it just won't have it. It'll just say there's something wrong.
Yeah, but I mean, there's not that much that can be gone wrong on there, is there? They're just in phase order.
Well, I suppose if I was looking at it technically, if it was me, first of all, if we got those phases wrong, we could end up with equipment going backwards in the engine, fans and pumps and all that kind of stuff. If they're right and all the pumps go the right way, off here, it just won't sync. So it won't cause any damage, but it would end up having to sort it out.
What's the most expensive mistake you've made?
I can't discuss anything that's happened on this gun now. I know I'm not that bad. You know, I used to drill doors wrong.
Oh yeah.
That's always it's not super expensive, but it's a real disaster.
Really annoying.
Or the classic 25mm hole instead of a 20.
Yeah, we've all been there. And then you say, do you know what I've done? I've put in a reducer, so you have the option for a 25mm hole in the future. Very forward thinking.
The best one I've seen on a job, you know, like fire alarm panels now just have a thing that reads out where the fire is.
Yeah.
In the good old days, they used to have what they call a mimic, was like a big, basically a plan view of a building.
Yeah.
And it had LEDs on. It was a specialist building.
Oh yeah, I've seen those, yeah.
So it had a full plastic drawing of the building with all these LEDs on.
Yeah.
And a guy on the testing team megged it 500 volts and killed the entire thing.
Oh no.
80 grand.
Oh my days.
And that was in about 2002, so that was a good 80 grand then.
I've not personally had a big one yet.
You'd remember, wouldn't you? You'd remember straight away.
I've had some near misses.
Yeah.
I've had a big near miss with 11,000 volts battery, DC, bear in mind, but still a lot. It wasn't a loss of life near miss, more of a loss of equipment, but it fortunately didn't pan out. That's a story for another day.
I tell you what, I don't like DC full stop.
DC.
Full stop.
Why?
Just it's dangerous.
I feel the trouble is, right, I did so much of the original solar work, domestic solar work that I've done. It's all been with Solar Edge, where you have to kind of try to get a shock on that because it's got the optimizers on everything, so it switches off.
Yeah, I've not had a play with that. I'm dead keen.
It's good. It's a really nice kit, but the trouble is, you get so used to that where it's only 1 volt per panel.
Oh, because it won't output till it sees the inverter.
Yeah, so it's only 1 volt per panel. But you get a bit complacent, and then I go back to working on a proper system with actual voltages there. I'm like, oh, I should probably remember there's 400 volts on this. Alrighty, so that now is wired in. So I'm going to show you quickly how these fuses work. So we've got the power coming in off of these tails here. So they're coming down and up and into here through these fuses, which I'm going to show you now how you install these. It will be then looping across to that and back out and over to the machine, and it will also be going up to here, which will be doing the grid voltages for this air-filled circuit breaker here. Let me show you how these go in, because I've just been doing it quite candidly all this time, and then Jamie's just shown me a much better way. See this little button here in the lid? You just push that in, push that button, and they just slip right in. Like that. Beautiful. So these are a GG breaker, but they're in an NH frame. So all the gubbins and the internals inside of these are GG. The outgoing is 100 amps. So we've got 120 and 100. So they just slot in like that. Oh, I need the cover on that on the top. That's all torqued up and checked. So that will literally just slide in like that, and then they're on. Pretty cool stuff. Right, we're having an absolute nightmare. The thing is, sometimes the real electrical industry isn't all bow and lace and pixies and, I don't know, name something sweet, Jamie.
Fluffy kittens.
Fluffy kittens and anything else?
That's all I can get away with, to be honest.
Sometimes it is just graft and it's awful. But yeah, we're here and we're having a problem, which is something which no one could have predicted, and it's out of our control. This morning, my van broke down, so there was that. This is not my X Factor story, so I'm not going to go into it. But Jamie, cut to the chase. What is the issue we're having here?
These fuse carriers are made by a company called Merzen.
which usually are good, right?
Really good. No problems with them, and I've used them loads and loads and loads. But this morning, you noticed and I noticed straight away.
Just felt a bit flimsy. It was like it just cracked a little bit.
This carrier, yeah, the lid's okay. So I'm guessing the top. These are made separate in the factory, yeah. So this bit, I've never met before.
No, and they're fine. They've got a bit of flex.
Fine.
Whereas this,
the back plate, this snapped off, then this snapped off. These are rigid, and obviously because it's broken, I've given these a hard time to try and snap them. I suspect, because when this bit fell off as well, and I piddled it with my finger a bit, and it just snapped.
Bearing in mind,
I think it's a bad
all
casting.
of this has to be torqued up, right? This has got to be torqued to 10 Newton meters. It snapped at about 6. So it's a manufacturing issue with that Merson device.
I think the moulding, whatever the polymer, I went like that one earlier into it, and it's just snapped. You can see there, I put my finger down and it broke off. That's not right. So unfortunately, even though we've stopped here till 10 to 9, if we energise that, this cable here, this is the first carrier after these.
So the potential fault current on that, if that touched that earthed back plate, oof.
Well, there's 2,500 amps on it anyway, and then the transformer's only outside, so the prospective short current is massive, so it would be worse than the job we came here to fix, so it's just not worth it. So you've obviously rang the manufacturer, we're going to have to swap it. The only problem is, it doesn't get the engine on, but we think we can do that, don't we? We think we can get something working.
We've got a way of getting some of the power on, enough that they can start to warm the engine up, and that they can get the lights on in order to service it before they turn it on. So we've got that, but we're going to work on that tonight, but we're not going to film that because, to be honest, this is where sometimes the job takes priority over the content. However, there is one thing I'm going to really quickly show you because I'm quite proud of it. So say bye-bye, Jamie.
Bye-bye, Jamie.
Here's not the thing that I'm proud of that I want to show you. The thing that I'm proud of that I want to show you is just outside. So we're here in the Magic Van. I'd love to tell you why it's a Magic Van, but I can't. Atmosphere off. It's David Bowie. The thing is, I tried to sell it, but I forgot that it was Magic, so I thought it was too much of a risk. The reason why I've been wanting to sell this van is because getting inside of it, because I'm quite tall, to get inside, to get to all my boxes, is heavy and it's tiring, like me. Whereas, I've devised a solution. Woohoo! Yeah! How cool is that? So now, I can be outside of my van. See, I am firmly outside the van, stood up, back straight, and get to all of my things. So it's just a case of basically putting that whole drawer on runners. And this cost me a grand total of £160 to do. What that basically means is that with that little invention, this van will work all right for me for now. Because I was thinking about getting a new van, but I'm like, it's a massive waste. I don't really care what van I'm driving, to be honest. As long as it's clean, it's smart, and it's tidy, which when I'm not finishing work at midnight 2 days in a row, it is usually tidy. I don't really care about having the latest, flashiest thing. So I'm happy with that, and I'm proud of that. So I thought I'd show it. Do you know one thing I'm grateful for? All these late nights, I don't have to go home and do paperwork because I use Tradeify. My wife now, when we're driving home, she'll be doing the invoice for the day. By the time we get home, done, no paperwork. If you want to try and minimise the amount of paperwork you do in your evenings and get a similar system like me, where it's all online, on your phone, any computer, wherever you are in the world, even if you live in Blackpool, apparently it even works there, go try it. You can try it with my code and yeah, see what you think. No credit card details needed. Thank you so much for watching. If you're interested in more of this type of stuff, it will be much better videos when we're not under so much pressure, and also as I build trust within this company, I think they're going to give me more and more interesting jobs. Like, this is quite a basic call out really, it's just been a nightmare with parts and issues and blah blah blah. And also we only got it last minute, so we arrived here late anyways. But if you want to see more of these types of videos with interesting gas plant, anaerobic digestion, all the wicked things of the world of engineering and electrics, then leave me a comment down below. Always like hearing from you. Thanks for watching. Bye.